Okay, so I want to do a real quick recap of what the derivative is from the last video. I want to show a couple of special cases that we got to watch out for, domain issues and stuff like that. And then I'm going to do an application problem, a real life problem, just so you can see it, because I want you to have it in there. And then we'll be done with this section on definition by derivative. You can do your homework and all that good stuff. Okay. So as a reminder, the derivative of f at x, which we note it as f prime of x, um, is the instant rate of change Okay, IROC given by f prime of x equals the limit as h goes to 0, f of x plus h minus f of x all over h. Okay, so that's a nice, pretty definition for us. We can keep that somewhere that we can see it. That'll be on a formula sheet somewhere. But I need to add one little thing in here, and that is if the limit exists. Okay, that's something we haven't dealt with yet, and I want to deal with that. So, if the limit exists, it's called differentiable. You can take the derivative, all that good stuff. If the derivative, if it doesn't exist, then we're in trouble. Okay, so as a reminder, let's look at the idea here of the derivative and what's going on, the slope of the tangent line, all that good stuff. So I'm just going to give you a little example here. If you know, and this will be nice, f of x equals 4x minus x squared, and that the f prime of x is 4 minus 2x. Okay, so hopefully we know that by now, right? We actually did this problem in the last video. So if you know that, then find the slope of the tangent line at the following points. So, in other words, we need this derivative because it's tangent line, right? It's instant rate of change whenever I'm dealing with tangent because that's 1 point, okay? So this is actually a multiple part problem. It says, what if x equals 0? Okay. If x equals 0 and we want the slope, then that means I'm dealing with the derivative, right? Okay, so I'm going to come over here for the slope, and I'm going to find f prime of 0. Okay, 4 minus 2 times 0, that's 4 minus 0, that's just 4, right? Okay, B says x equals 2. Okay, so I want you to think, oh, I need to find the derivative at x equals 2. Okay, so you can do that. 4 minus 2 times 2. And what do you get? 0. Okay. And then let's do one more. What if x equals 3? And I want you to do that one all by your lonesome. So think about it for a second. F prime of 3. 4 minus 2 times 3. I'm getting a negative 2, right? Is that what you get? I hope you're saying, I get -2, Dr. Webster. Okay. So the idea here is that the slope of the tangent line changes depending on where I am on x. So let's go back. I'm going to go ahead and take a graph of this. I'm going to use my graphing calculator for this guy. And we're going to put in the original 4x minus x squared. Okay. and graph that guy, and there it is. Okay, so what we're seeing here is whenever we put in x equals 0, we were right here, right? What kind of slope is that? Positive, right? It's going up. And then when we put in x equals 2, well, let's look. X equals 2 is right here. Okay, what we're saying is if we drew a tangent line to that graph, let me copy this guy over here so we can see it. Okay, it looks something like this. Okay, it's not perfect, but that's what it looks like. So what we're saying is over here, when x equals 0, if we drew a tangent line there, the slope was positive, right? It was, what was it? I got rid of it. Positive 4. Okay. And sure enough, that graph's going up there, right? That slope is positive. When it was x equals 2, we found m equals 0. Well, we know that that means that was a horizontal line, right? And that's going to actually come back to play for us a lot. So when we find the tangent line, the slope of a tangent line is 0, that means we're talking about this horizontal line. That's a special guy. We'll deal with him later. And then at x equals 3, we had m equals -2, right? So it was a negative slope. And sure enough, if I look at this graph, yep, it goes up, it flattens, and then it comes back down. So it is a negative slope there. So sure enough, all this derivative stuff that we found whenever we plugged into the derivative here, 4, 0, -2, it actually plays out in the graph and we can see it, and that's very nice, right? Okay, so that is actually something we would like to see happening so that these derivatives actually tell me something about what's going on. Okay, now I promised you some special case guys, so here we go. A couple of examples. Find f prime of x whenever we have f of x equals 1 over x. Okay. And so far, the only way we knew how to do that is our 4-step process, right? So that's what we're going to work on using IROC, all that good stuff. So the little bit of a problem here is that this is in the denominator. The x is in the denominator. And this is what I tried to get at a little bit on that last video that we made. We're going to have to be a little bit careful here because what we can't have is when we finish, we can't have h on the bottom and h go into 0, right? That's going to cause us problems. So we're going to deal with that in just a second. Okay, so herein lies the deal. We're still going to use our 4 steps. Step 1. Okay, we're going to do f of x plus h. That means I'm going to come in here and I'm going to plug in on the bottom where I see an x. I'm going to plug in an x plus h. That looks a little bit light. I'm sorry. Okay, there's no problem with that per se, the way it is, but I'm going to go ahead and figure out what's going on for the next one. So it's going to get more complicated as we go along. Step 2 is f of x plus h. There wasn't anything to do here, right? Because it wasn't squared or anything. Minus f of x, so minus the functional value. Well, that's 1 over x plus h minus 1 over x. Now it's starting to look a little bit on the complicated side. And in fact, I don't want to leave those like that. I want to go ahead and cram those together to make one fraction because that looks ugly. So you'll have to think for a minute about common denominators. The common denominator between these two fractions is an x times an x plus h. This guy has the x, but I need to multiply him by a. I'm sorry, he has the x plus h. I need to multiply by x. This has the x. I need to multiply by x plus h. Okay, so my common denominator here is x times x plus h. Okay. And then we have to say, well, whatever we did to this fraction on the bottom, I need to do the same thing on the top. So I multiplied the bottom by x. I need to multiply the top by x, right? Same thing over here. Whatever I do to the bottom, I multiplied it by x plus h. I need to do that to the top. So I need to multiply the top by x plus h. Okay, so that's what's going on there. Okay, now I can say, oh, we have the same denominator. Let's simplify this a little bit. X over x times x plus h minus x plus h. I need to keep those parentheses, right? Or distribute this negative through, whichever one you see. I'm going to distribute it in just a second, but I'm not there yet. Okay. So we got the same denominator. We've now got what's going on the top. I need to distribute this negative sign. This is x minus h. Okay. And so now we see, oh, look, those x minus x guys, those go away. This is a negative h over x times x plus h. Okay. That's all right. That's not terrible. Maybe we don't like working with fractions with variables in the denominator, but we can do it. Okay. Step 3. What's step 3? Divide by h, Dr. Webster. You would be absolutely correct. Take whatever you had before, divide it by an h. Now this becomes tricky because I want to take this just as it is. And I want to divide that whole thing by h, right? But we don't like doing that. We don't like a fraction inside of a fraction. So if you remember some of your algebra stuff, how can I get rid of this divide by h? And the answer is to multiply by 1 over h. That way that guy will go away. And whatever I do on the bottom of the fraction here, I do the top of the fraction here. So all of this has to be multiplied. So it looks a little bit icky, but hey, look here. Those h's are going to go away. I have a negative 1 on top. This bottom went completely away. X times x plus h, right? Negative 1 over x times x plus h. Okay. And so I can go straight on to x step 4, which is take all of that and make the limit as h goes to 0. Okay, take that limit as h goes to 0 of all this stuff. Okay, before I can, well, I can do this at either spot I want to. Before I go through and plug in h equals 0, though, I kind of want to make this prettier for me. Well, you can do it wherever you want to, but I want to make this a little bit prettier. So I'm going to say this is the limit as h goes to 0 of negative 1 over, and I'm going to distribute that x through to make it prettier. X squared plus xh. You could do it here and it would be fine, and then you just have the x squared. But I like seeing it there because when I take this limit, that term goes completely away, okay? And you're just going to get negative 1 over x squared. Okay, no problem there. And we don't have a problem taking this limit as h goes to 0 because we had this other term down there. If it had just been h down there and I went to go take that, then I'd be dividing by 0. Now I'd be in trouble. But because I had, oh, excuse me, this x squared, I am safe. Okay, we are going to be okay there. No worries. Okay, what is the one thing we have to worry about, though? X can't be 0, right? If I take 0 and square it, I'm going to get then I'm still going to get a 0 on the denominator, and then I'm still going to be in trouble. Okay, so that's just a little bit of, that's a weird thing that happens. We will find a shortcut method in the next video that makes it much easier to deal with this guy whenever x is in the denominator. But remember, the two spots we normally have problems in domain and stuff like that, dividing by 0, taking the square root of a negative number, okay? So whenever I deal with, oh, excuse me, things that are written with variables in the denominator or things that are written with variables inside of a radical, I just know things are probably going to get a little bit complicated. So that's what happened here. It's a special case. You can still do it. We still got it to a good answer. We didn't have any problems, but we do need to watch out for if there's only an H on the bottom, I can't divide by 0. Okay. So that's one of the things that's weird that happens. Okay. Here's another thing that could happen that's weird. Okay. Find f prime of x. If f of x equals square root of x plus 2. Hey, what did I just say a second ago? Where do we have problems? Dividing by 0 and taking the square root of a negative number. So this is our other kind of weird case. We're going to deal with it. It's going to work through pretty nice and smoothly until we get to one particular spot. Plug in f of x plus h, right? If nothing else, hopefully you've gotten a lot of practice right now plugging in this f of x plus h, right? It goes inside of the square root because that's where my x guy is. Plug that in wherever the x is. Okay, I can't do anything with that, so just leave it alone for now. We'll mess with it in a minute. Don't go trying to do weird math on me here. Okay, so step 2, f of x plus h minus f of x, which is the original function. Okay, well, I've got this stuff here, square root of x plus h plus 2 minus the original function is square root of x plus 2. Okay. Can I combine those two? No, I can't. The only thing I can do here to simplify this is go ahead and distribute that negative sign through. That'll make it a little bit nicer for me. Square root of x plus h plus 2 minus the square root of x and then minus 2, right? And hopefully we see the plus 2 and the minus 2. Those will go away. So I can simplify it just a tiny bit, but I can't really do anything with those square roots. So don't stress out about them. Just keep them alone. Okay, the 2's go away. There's my step 2. Okay, step 3. Divide by h. All that stuff, divide by h. Okay. Square root of x plus h minus the square root of x all over h. Okay. And then this is where we go, oh, we're in trouble because what happens? We're working along just fine, and all of a sudden, step 4 says, take the limit as h goes to 0. In our class, we know that that means plug in h equals 0, right? But what did I just say a minute ago? Can we divide by 0? No. So this is going to cause a problem. In fact, if you were on your calculator, it would say error. Okay, that's a bad thing. We can't divide by 0. Okay, so we need to take a step back, and we can do this. We actually can do this. We just need to take a step back and figure out something else we can do so that we're not plugging in. Right here's the problem, right? Plugging in h equals 0. So we're going to take a step back and we're going to do one other thing before we get to step 4, and that is deal with this thing. And so I'm going to come from here. We'll come back to step 4 in a minute. Go back to step 3. And we're going to do something that's called rationalizing the rationalize the numerator. Okay. Where you might have seen this before, let me give you a little scratch work off to the side here. If you had something like 1 divided by the square root of 3, okay, we know that mathy wise, we're not supposed to leave a square root in the denominator, okay? So you might have done something that was called rationalizing the denominator, which was basically if I multiply square root of 3 times square root of 3, then I can do that math, and now I have square root of 9 in the bottom. Well, what's square root of 9? That's just a 3. And so by multiplying by whatever this radical is, I actually get rid of the radical out of the denominator, okay? The trick here is whatever I do to the bottom, I have to also do to the top. So on top, I multiply by a square root of 3 as well. And lo and behold, we have square root of 3 over 3, okay? So that's called rationalizing the denominator. One more of these, just because I wanted you to see it. What if it was 1 over 1 minus the square root of 3? Rationalizing the denominator. Again, you should have seen this stuff in the past. This should be a review. To rationalize that denominator, we do basically like a difference of squares whenever you're factoring. If you remember how you do a difference of squares, it's the same exact term, 1 and square root of 3, but you change the sign in the middle, right? Okay. If you remember on a difference of squares, what happens when you do that? 1 times 1 is 1. We get plus the square root of 3 minus the square root of 3. Those are going to cancel, right? They're going to go away. And then I get minus the square root of 9. But hey, the square root of 9 is okay, right? Because that's going to be a 3. And those two guys in the middle are going to go away. Okay. So that's what happens when we do a difference of squares. And that's what happens whenever we rationalize the denominator here, but it's a binomial, 2 terms, right? So the only thing I have to remember is to go back. Whatever I multiplied the bottom by, I have to multiply the top by. 1 times that guy is just a 1 plus square root of 3. That's a 9. Square root of 9 is 3. We're good. Okay. So I'm out of space, so I don't want to deal with that too much. But this is okay. That's how we rationalize the denominator. We're going to use this idea here, but we're going to rationalize the numerator. Okay. So in other words, I see I got a couple of square roots in there, and I want to square root of x plus h minus the square root of x all over h. I want to rationalize the numerator by dealing with that concept that we had, like a difference of squares. Well, how can I do that? It's the first and second terms stay the same. Okay. And instead of a minus, I get a plus. Okay. We'll figure out what goes on the top in a second. But the big thing for us is whenever I multiply by the same thing on the denominator, what we're going to see is that h isn't going to be by himself anymore. So we're going to be legal on this step here in a minute. Okay. So don't stress out. It's going to work out okay, because I'm going to just get rid of those guys, right? Okay, so let's see what we got here. I need more space for sure, more space. Okay, here's what happens. We need to multiply out this times this, like a difference of squares. We're going to multiply those out. So I'm going to have square root of x plus h times itself or squared, right? Dang it, that's so light. This one's not much better. Square root of x plus h times itself is squared. Okay, here we go. This guy times that right there. Okay, so plus square root of x times the square root of x plus h. Okay, we don't know what that is, but we don't care because whenever we do this guy, we're going to get a minus that guy. And remember what happened here? This guy's in the middle went away. Same thing here. I've got a plus of that guy. I've got a minus of that guy. They're just going to cancel out. It's all good. Okay. And then the very last step when I multiply, I'm going to get a minus square root of x squared. And we'll figure that guy out in a second. Okay. On bottom, we're not going to do much with this. I'm going to leave it sitting. The h is going to be multiplied by all that stuff because I know that something's going to reduce out here in a minute, so I don't want to have to undo my work. So I'm just going to leave it like that. Ooh, this is ugly. You're going to love the shortcuts when we get there. Okay, I promise you, you're going to like it. For right now, this is all we got. Okay, so what happens? Square root of x plus h times the square root of x plus h. Okay, the square and the square root, those go away, and the x plus h is going to fall out. This positive and that negative, those are going to go away. Minus the square root of x and the square of that, those are going to go away, and I just get an x. And again, we're going to leave the bottom by itself. Leave it alone for a second. Because hopefully we see what's going on. What's up at the top? Those went away. I got an x plus h minus x. The x and the minus x, those are going to go away. I'm going to have an h times all this stuff. We don't care about all that stuff. What we care about is this is going to be h divided by h, and that's going to be a 1. Okay, so it looks really ugly, but this is what I have whenever I rationalized numerator. Rationalized the numerator. And the nice thing is, if this is my answer from step number 3, then now I can walk happily into step number 4, which is take the limit as h goes to 0 of that ugly guy. Okay. And it's not gorgeous, but it's not bad either. This guy's going to go away. This guy's going to be a 0. I end up with 1 over the square root of x plus the square root of x. Hey, can we do something with that? Combine like terms. That's what I hear in my head. Yep, I got 1 square root of x's, 2 square root of x's, right? So this is 1 over 2 square roots of x's. I'm not stressed out anymore about the h becoming 0. It's not a problem because it went away. The only thing I have to worry about is in my domain, x can't be 0, right? Just like in the last problem we did, x can't be 0 because I've got that on the denominator, so I can't have it. All right. Okay, those are the 2 really weird kind of cases that you're going to deal with. When we get to shortcuts, you're going to go, oh, this is so much better, but I'm sure that there's one of each of those in your homework. So I apologize in advance. Go ahead and do those. I have one more example for us here, and then we will be completely done with this section. I just wanted to break it up into 2 different videos because it was getting really long. So you've seen all the special cases kind of stuff. I have an application problem. So it looks like this. A still ball is dropped. Still ball is dropped. And we have a velocity function. Okay. That looks like y equals f of x equals 16x squared. Okay. Real quickly, what's that guy look like? Think to yourself. It's x squared. It's a parabola. It's facing upward because this guy's a positive 16. Absolutely. Okay, so that's what my velocity function looks like. Okay, so x is going to be time in seconds. Okay, so in other words, if I don't drop it at all, x equals 0. 0 squared is 0 times 16 is 0. You haven't dropped it, your velocity is 0. Oh, real quickly also, what's velocity? Velocity is a very mathy slash sciencey word that we use for speed. Okay. So what we're talking about here is the speed of the ball as it's dropped. Okay. That's what we're looking at. Okay. Don't stress out when they have weird words like velocity. Don't worry about it. Okay. The problem, all of this will be given to you in the My Math Lab homework. The problem says find the average velocity from for between, actually, I think it says x equals 2 and x equals 3. Okay. So the average velocity between x equals 2 and x equals 3. All right. So average, that's two different ones, right? 2 points. I've got two x values. I'm going to find 2 points, 2 comma and 3 comma, figure out what these y values are, and then we will deal with our AROC. Okay, so let's go with it. 2 squared is 4. 4 times 16 is 64. So this point is the point 2 comma 64. 3 squared is 9. 9 times 16 is 144. Notice that I don't know those numbers. I knew 16 times 4 was 64, but I didn't know this one. So don't feel bad if you have to get your calculator out. It's all good. Okay. Average rate of speed. Let's find our, average rate of change. Okay. So let's find our speed here, average velocity. And I'm just going to subtract, right? 144 minus 64 over 3 minus 2. This is 80, right? Over 1. So, this was in feet. Okay, so it's 80 feet per 1 second. There's my speed, 80 feet per second. Okay, average velocity. That's what they want to know. Okay, so part B says find the AROC between x equals 2 seconds and x equals 2 plus h seconds. Okay. And they say h can't be 0. It can't be 0 because if it was 0, we'd have 2, right? And then we'd have the instant rate of change. Okay. So in the case we just did, what was my h? Remember, that's the gap. The h here was a 1. Okay. So they're saying instead of finding the difference of just 1 here, they want me to find a generic difference of h. Okay. So we can do that. We have to go to the AROC formula. It says, in this case, f of 2 plus h, because they're telling me 2 plus h, minus f of 2, we'll figure that out in a second. We already know it, over the h, right? And by the way, if I did off to the side, 2 plus h minus 2, those would go away and I would get the h that comes out of the formula, right? So that's just scratch work. So we see, hey, that's where they get this from. Okay. The deal is, I don't know what f of 2 plus h is, right? I'm going to have to plug that in to my original function and see. Okay, so where is my original function? There it is. 16x squared, right? So, and that's fine. We can do it. I just have to know what the formula is. 16 times, instead of x, I'm putting in 2 plus h squared minus, hang on a second, we actually know what f of 2 is. We already found it. 64, right? Use your work if you already have it. If you have to stick it back in, you can do that, but we already know what it is, so we're good. Okay. Let's do some math on this thing. 16 times 2 plus h times 2 plus h. Okay, if you don't remember, we're going to FOIL this guy out. 16 times 2 times 2 is 4, plus a 2h plus a 2h is going to be plus 4h's, and then plus h squared. Okay, and then I need to distribute that guy, right? The 16 needs to go through. So, hey, look, 16 times 4 is 64. That's going to work out nicely for me, right? Okay. Plus 64h plus 16h squared. I'm out of room, I'm sorry. Minus the 64. I just want to show those 64s go away all over h. Okay, let me rewrite this so we can read it. Sorry, I ran out of space. So I had 64h plus 16h squared over the h. Okay, we need to get rid of that h guy, so let's go ahead and factor out an h on the top. 64 plus 16h. All over the h, those h's go away. That's what we were after. 64 plus 16h. All right. So remember, this is the average rate of change between 2 and x equals 2 and x equals 2 plus h. Okay. So what the heck does that mean? What if I wanted 5 seconds? Okay. So the one we did earlier was for between 2 and 3 seconds, right? But what if I wanted to know between 2 and 5 seconds? What gap, what's my h? Okay. If I wanted 5, it would be 2 plus h. My h would be a 3, right? Okay. So if it asks me, and it didn't, but what if h equals 3? Then I just plug that guy in, right? Okay. So I'd have 64 minus 16 times 3 is 48. I'll do that math. Dang it. 6. Is that 16? Yeah, it's 16. Just double checking myself. I don't trust my arithmetic. Oh, it is not. Well, it would help if I did the math on my calculator correctly. 64 minus 48 is 16. So, yay. Okay, so that would be between x equals 2 and x equals 5. So doing this generically like this is a way for them to come back later and say, oh, what if, and they do this in your homework. That's why I'm telling you. What if the h is 3? What if x is 5? What if x is 7? Well, then if x is 7, the h is going to be a 5. What if the x is 8, the h would be a 6, right? So you got to find that gap whenever you're doing that kind of thing, and then you'll be okay. All right. And the last possible thing for this particular problem that they could say, part C, find IROC. Okay. And again, we should be really good with that by now, because all you're going to do is take your average rate of change, right, and find the limit. That fourth step, right? The limit as h goes to 0 of that guy. Well, that's not hard to do, right? Make that h a 0. The IROC here would be 64. So the instant rate of change for this ball dropping is 64. And just to keep up with my units, it was feet per second. Okay. Instant rate of change at x equals 2. All right. So that's kind of one of those problems where you would need to have an application problem. There are stuff like that on your homework. And I just wanted to make sure you're all good to go there. So good luck on your homework. Let me know if you have questions. Thanks.